Guys, wanna grab some food?
Yeah.
Okay, let's go to the meat stall.
Yeah.
Let's grab some butter and bread now. What a perfect combo.
Wait, hold on, guys. Whoa, it was 7,000 yesterday, but now it is 10,000. Unbelievable. The price is dropped.
Why is it so expensive now?
Guys, I won't buy bread anymore. And the best food prices, so.
Wait, why does that even matter?
It looks like the price of one thing affects the price of another thing.
Yo, welcome back to Analytics Brand Channel. I'm here to help you develop your knowledge about mathematics for business. Have you even wonder why can change in the price of good product affect the demand for another? In reality, goods do not exist in isolation. They are interconnected in the market. To give you a clear roadmap of our discussion, today we have to divide our presentation into 5 key sessions. Into the market's product really exists in isolation. The demand for one is often set by the price of another. To explore this, mindset is in mind to distinguish here white bread and butter and gasoline and diesel. By estimating their cost price elasticity, we aim to compare how these goods interact and gain insight into consumer behavior. According to market, goods are classified based on their price-demand interaction. Substitute are good using each other. When the price of one rises, the demand for another increases. Complementary goods typically consumed together. When increasing the price of one leads to decrease in the demand for each comes back. To quantify the relationships, we use two price analysis metric. The resulting sign, whether positive or negative, is the primary determinant used to classify the relationship between two products in an academic context. The formula is straightforward: is the percentage change in quantity demand for goods is divided by percentage change in the price of Wise, this allows us to see exactly how sensitive one product is to price fluctuation of another. For substitute good, the elasticity coefficient is positive. They confirm that the price of one good and the quantity of the other move in the same direction, proving the consumer perceives them as interchangeable alternative. Conversely, complementary goods use a negative sign. This invert relationship so that as the price of one product rises, the demand for its complement. For reflecting the joint consumption pattern, looking at the graphs on this slide, you can see, looking at the graph slide, you can see the visual line distinguish the two relationships. The upward sloping line represents the substitute and where variable move together, while the downward sloping line illustrates the complement where variable move inversely. Beyond the side, the magnitude reflect the trends of the relationship. Higher value indicate close substitute or strong complements. For our methodology, we choose the simple percentage chance method over the midpoint formula to better preserve data and precisely the capture points specifically variation in our datasets.
Today we analyze bread and butter as complementary goods using secondary data sources of verify and reliability and accuracy. Data on butter production is sourced from U.S. Department of Agriculture, while data on retail prices of bread are collected from Federal Reserve economic data. The butter production data is measured in millions of pounds, and the retail prices of bread are given in US dollars per pound. These are both well-established sources that are commonly used in economic analysis. If we look at the first line graph here, we can see the changes in retail price over time, while the secondary line graph we can see the changes in the butter production across the same period. The dataset covers the period from February to December 2024, where each observation represents 1 month. In terms of classification, the dataset is time series, quantitative, and monthly in frequency. This means that the data points are collected sequentially over time, and all variables are expressed numerically and all variables are continuous, which makes them suitable for statistical and economic analysis. Overall, the dataset is primarily designed for determining the cross-price elasticity of demand for bread and butter, which are examples of complementary goods. By structuring the data in this way, the visualizing key variables through these through these line graphs provides a clear foundation for analyzing the relationship between two goods over time. Based on the input for bread and butter, we are using the first two data points as the representative sample for our calculation. Look at the table. The price of bread and the quantity of butter for January and February are 2.033, 217.081, 2.006, and 197.802 respectively. First, we look at how the quantity of butter changed. By taking the difference between February and January and dividing it by the initial January volume, we see a decrease of 8.88% in butter consumption. Next, we calculate the price shift for bread. Following the same logic, the price of bread decreased from 2.033 to 2.006, which represents a 1.33% drop. Finally, to find the elasticity, we divide the change in quantity by the change in price. Our calculation results in 6.687. We apply the same calculation to the remaining months as shown in the table. While some individual months vary, the overall average cost price elasticity of demand is minus 29.138. Since this average is negative, we can conclude that bread and butter are complementary goods. This means they are typically consumed together, where a price change in one affects the demand for the other in the opposite direction. So to talk about the interpretation, you can see that the calculated average cost price elasticity of demand for a 12-month in 2024 is strongly negative, which is about minus 29. And in economics, you can see that an overall negative cost price elasticity indicates that the two goods are complements. So in specific, you can see that the inverse correlation here, because the general trend shows that the increase in the price of bread is associated with an increase in the quantity of butter demanded. For example, in March, you can see a slight price change of about 0.45% increase in bread was accompanied with about 6.55% increase in the quantity of butter demanded. This happened because these two products are typically consumed together, so when the bread becomes slightly cheaper, the consumers may buy more, leading to the higher butter consumption. Volatility and extreme, you can see that unlike smooth annual data, this monthly data test exhibits extreme mathematically volatility and seasonal influences. For specifically, you can see that in June, the elasticity hits an extreme of about minus 176, and this is a mathematical artifact occurring because the potential change in bread price was incredibly small, which disproportionately inflated the elasticity value when dividing the quantity change. So you can see that in December, the elasticity was about minus 65, and the price of bread barely dropped about 0.21%, but the quantity of butter spiked massively, and this suggests that the butter demand here was driven heavily by the seasonal factors like the holiday baking rather than purely by the price of bread.
Wait, guys, although we saw bread and butter going together, right?
Yeah, like when the price of order of the one is changed, the other is affected too. They are connected.
Yeah, but not all products are like that.
What's in there, man?
Then take diesel and gasoline, for example, they are not usually used together.
Oh yeah, in fact, they're actually compete with each other.
Look, guys, the price just dropped.
Then people will likely use gasoline instead of diesel.
So when the price of one product goes down, the demand for the other product also goes down.
So in the next part, we will be talking about the data set used in substitute goods. So the data set used in this analysis examine diesel fuel and gasoline as substitute goods is sourced from reliable institutions, including the U.S. Energy Information Administration and Federal Reserve Economic Data. So the data cover a 3-year period from 2022 to 2024, which is observation representing a full year. It includes two key variables, diesel fuel production measured in thousands of barrels per day, and gasoline prices measured in US dollar per gallon. So this dataset is structured at an annual level with simplified analysis and highlight overall trend. Even though more detailed data could be used, it combines elements of both time series data and extract changes over time and cross-sectional data and compare to related variables. So the main purpose of the dataset is to calculate cross-price elasticity between diesel and gasoline. Since both are widely used for the transportation, they are considered substitute goods, meaning a change in the price of one is expected to affect the demand for another. Based on the data, both diesel production and gasoline prices show a declining trend. Therefore, positive cross elasticity is expected between the two goods.
Due to the output of the production for diesel and gasoline, the first two data points have been selected and representative numerical sample for our equation. According to the table, the quantities for diesel and gasoline price at the end of 2022 and 2023 are 2,031.609 and 2,959.406, 2,091 and 2,053 respectively. During the period 2022 and 2023, there were a decrease in the amount of diesel, which went from 3,031,609 to 2,959,406, representing a minus 2.38% decrease, while the unit price of gasoline fell from 2,091 to 2,053, minus 1.23% decrease. Cross-price elasticity equal 1.93, reflecting an elastic relationship, which implies that diesel and gasoline doing the same thing for the remaining years. As shown in the table, as the cross elasticity of price is more than zero for our periods, the demand for diesel changes oppositely with respect to change in gasoline price, indicating that they are substitute products. Moreover, their value exists one implying electricity substitutability.
The cross-price elasticity of demand for both periods is consistently positive, confirming that diesel and gasoline are substitute goods. However, the intensity of this relationship has shifted significantly over the past 2 years due to economic and geopolitical forces. From 2022 to 2023, the calculated cross-price elasticity was 1.93, indicating a strong substitute relationship. The data shows that the price of gasoline decreased by 1.23%, while the quantity demanded of diesel fell by 2.38%. Critically, in 2022, there was the Russia-Ukraine conflict, causing massive spikes in global oil prices since Russia is a major fuel exporter. In the short run, substitution is difficult because consumers and firms cannot switch fuel types instantly due to equipment constraints. Therefore, daily consumption remains tied to the existing capital stock, and the cross-price elasticity is not as high as expected. In response, the U.S. implemented strategic petroleum reserve releases to stabilize gasoline prices. As a result of this government intervention, fuel prices stabilized, and this forced industrial consumers to reevaluate which fuel was more cost-effective during times of geopolitical unrest. Moving on to 2023 and 2024, the calculated cross-price elasticity increased to 3.39, signaling that diesel demand had become hypersensitive to changes in gasoline prices. The data shows a small percentage decrease in gasoline prices of 0.95%, while diesel consumption dropped by 3.22%. The cross-price elasticity increase demonstrates that substitution became easier over time. After an entire year, consumers had enough time to optimize costs and change their fuel-consuming capital. However, the space still saw geopolitical instability as OPEC Plus cut production and heightened tensions in the Middle East, creating shipping disruptions. These logistical shocks created and maintained the volatility seen in 2022 to 2023. As a result, logistics companies had to manage more diverse fleets, allowing them to prioritize the usage of gasoline-fueled vehicles over diesel ones as prices fluctuated, driving the high cross-price elasticity observed in the data. These results suggest that diesel and gasoline are substitutes in the U.S. market. From the data, we can conclude that a price change in gasoline in the US market has resulting impacts on diesel consumption as consumers substitute fuel sources as prices fluctuate.
So next up, we will talk about limitation. Despite providing useful insight, the analysis has several key limitations. First, the data volatility is an issue. Money data can fluctuate significantly, sometimes producing inconsistent elasticity value that may not reflect the true long-term relationship between goods. Second, the sample size is very small. The diesel and gasoline analysis only covers a short period from 2022 to 2024, resulting in very few data points. This limits its reliability of conclusion and may exaggerate changes in elasticity. Third, it is an augmented variable bias. The model only considers price and quantity, ignoring other important factors such as economic growth, government policy, or the rise of electric vehicles. These factors can strongly influence demand but are not included in the calculation. Finally, the analysis does not distinguish between short-run and long-run effects. In the short run, consumer may not change behavior quickly due to fixed habit or access. However, in the long run, they are more likely to adjust, leading to different elasticity outcomes.
Okay, so to wrap up our presentation, for bread and butter, we observe a clear joint consumption pattern describe some seasonal noise in the data. The strongly negative price elasticity confirm they are essential complements for gasoline and diesel. We found a competitive relationship that actually strengthened over time as consumers and business have more time to adapt their vehicle fleets. Their sensitivity to price change in increasing significantly in closing cross-price elasticity is a powerful diagnostic tool for any economist or business leader. However, it must only be integrated within the broader context of market dynamics, such as seasonality or long-term structure shift. Once again, thank you for your attention, and we are now open for any questions. And don't forget to subscribe and like my video.